All right. So we will continue with the application exercise. We can draw the cash flow diagram. As you can see that we can use now upward arrows for maybe depositing and downward arrows for withdrawing. If we have, for example, costs and we have also benefits, we can use the benefits or revenues on the upward arrow and the costs as downward arrows. Here we can put the deposits as upward arrows. All right. So we have 0, 1, 2, and it continues like that. We have up to 17 years. And then the student goes into university. So 18, 19, 20 and 21st birthdays, he is going to withdraw these 60K each year. His father will be in trouble, you know. All the money has gone. So you have to find out the value of A. How much he has to put equal amount such that he has enough money, so if the funds are withdrawn, they have enough money there in the bank account. How to do it? Again, bring this 4 years because they are equal payments. Just use this formula, present worth. But when you use the present worth formula, remember that the money will not go over here, it will go at the start here, right? So we have, we can say P17, let's say, is equal to 60,000 into 1.06, I suppose it is also 6%, 4 years minus 1. And we have 0.06 multiplied by 1.06 raised to power 4. So P17 is now there, and it is now like a future value if we want to find out what is A. Remember that when we said A and we have a future value, we can use this formula. Okay, so if you first use this value, and this will be a future value, we can say F17 is equal to P17, the future value for using now this formula, okay, to find out A. So we have A is equal to that P17 which you have calculated, okay. Call it F17 now here. F17 is equal to P17, and we have F17, and we have this sinking fund factor. I is 0.06. This is also called sinking fund factor. Okay, within the bracket. 1.06 raised to power 17 minus 1. That will be your A value. Clear?
Doctor, I think the assumption is on 18, 19, 20, 21, there is no more contributions.
No more contribution, that's right. It is not assumption, but it is given as a part of the problem. So if you see over here, he says that the fund pays 60, he puts only first to 17th birthdays, sorry. He is only putting for first through 17th birthdays. So it's a given. It's not an assumption over here. We are given this situation that he is just putting for first 17 years. Okay.
7,000.
So if what's your name? Muhandas? Muhannad. Sorry, you will be Muhandas also, inshallah. Muhannad, what is your age?
7369.
$7,369. Okay. Now there is a slight twist in this problem. It says that if the fund is not equal, first year it is 60,000, second year is 67, third is 75, and then 83,000. How you will do it? You can treat them separately. Each year you can bring them back. All right?
And then you do the same.
And then you do the same. Exactly. We will continue now. Now the rest of the lectures we have some cost concepts, something about inflation, escalation, and depreciation. These concepts are there: opportunity cost, capital cost, fixed cost, variable cost, sunk cost. Different cost concepts are there. We will also talk about some price concept, the difference between economic analysis and financial analysis, what is the difference, and then we will talk about this, the shadow pricing, etc. So let's continue our lecture about escalation and inflation. Inflation is when we were talking about the time value of money, we also talked about inflation there as well. Inflation is the purchasing power of the currency goes down. Purchasing power of the currency goes down. As maybe your grandfather is telling you sometime his story is that when he was young, he used to buy camel for 50 reals, right? Most of you have learned this from your grandfathers, such kind of stories, that we used to buy a goat for maybe 5 reals or something like that. This is because of inflation. The purchasing power of the currency goes down. Inflation occurs because if the government prints more currency, then the supply of money becomes more, and the demand, is the commodities are limited in that respect, so the commodities prices goes up, and that's why we see that inflation occurs every year. This is not only the printing of currency, by the way. It is also when the banks create loans. They create money basically out of nothing. And when they create loans, they do inflation. The second concept is escalation. Escalation is independent of this price rising. That is, it is also price rising, but because of limited supply. And the good example may be, we have seen earlier that there was a drone attack or whatever, the attack was on Saudi installations, and the prices of the oil went up. And this comes because of the limited supply and more demand. When you have limited supply, the demand goes up. It is regardless of the inflation. But we may have inflationary effects as well as escalationary effects as well. When both effects are there, the relationship is called the apparent escalation, which is 1 plus E, where E is the apparent escalation, and E prime over here, 1 plus E prime multiplied by 1 plus F. E prime is the real escalation, real prices going up, and F is the inflation. So there may be both the effects are there in the prices. The real prices are going up and also the inflation is occurring. By the way, the prices of electronics, we have seen that instead of going up, they have gone down. This is because of the technology improvement. When I came over here in 1998, I bought, I think, Pentium 3 or 4, I don't remember now. That was the best machine in the market, and I paid about more than 600 reals for that. And it was only the hard disk memory was only 10 gigabytes. You can well imagine that how the technology has improved. Now we have in our mobiles so much of memory is there. So the prices of electronics has a separate effect. It is not, we can say it is inflationary effect has not been seen over there, although inflation is there. So let's see an example of escalation and inflation. If you have any questions before I go to this example. Okay. So let's see example number 7. Suppose the price of the coal in year 2000 is $1 per gigajoules. Now the price is given instead of tons, it is given in gigajoules or energy unit, doesn't matter. And the annual inflation rate over the period is from 2000 to 2010 is 6%. Assume that the price of the coal escalates over the period at an average annual rate of 1.5%. The price of coal in the year 2010 expressed in $2,000 can then be. So here the concept of constant dollar and current dollar is given. The constant dollar is some constant year, and we can compare the prices according to that constant year. Current prices are taking into account the inflationary effects. So here, for example, the coal price in year 2010, when expressed with the constant year of $2,000, the prices have risen only 16% because of this 1.5% real escalation. However, if we take into account the inflationary effect, then we have the 1.015 is the 1.5% of escalation, real escalation, and 6% is the inflation. And as you can see, these are multiplicative. Multiplying this and raised to power 10 years, we have $2.08 per gigajoules. As you can see now here, that apparently it seems that prices have doubled, but in reality the prices have not doubled, but it's only increased 16% in real terms. In constant dollars they have increased 16%, and in current dollars they have gone up 2 times. So here the price is represented in year 2010 dollars, which means it is current, and this is with constant dollar with constant year of 2000. Okay, these concepts are used in comparing the prices, etc. So we can see over here that the inflationary effects, if we remove them, then the prices have only gone up by 16%. In planning studies, long-range planning studies, we can include or exclude the inflationary effects. Okay. In both cases, however, it is essential that all cost and economic parameters used in a study, we should be consistent. So if we are using the inflationary effects in our studies, then our discount rates should also be reflecting those inflationary effects. Okay. Next topic is of concept of opportunity cost. Opportunity cost concept is that it is the opportunity lost by not taking the optimal decision. Okay. Opportunity cost refers to a benefit that a person could have received but gave up to take another course of action. And since every resource, land, money, time, etc. can be put to alternative uses, every action, choice or decision has an associated opportunity cost. It is the penalty incurred by not taking the right decision. That is called opportunity cost. Penalty incurred by not taking the right decision. Let's see example 8, and this gives clearly that what is the penalty occurring if the lawyer is not taking the right decision. Suppose you are a lawyer whose salary is $100 per hour. You spend 2 hours in typing and organizing material per day, which you could have spent doing more law work. If you hire a secretary to do all the typing and organizing, you will have to pay the secretary $10 per hour. Then the opportunity cost incurred by not hiring a secretary is $90 per hour for those 2 hours. Means that you didn't take the optimal decision. The optimal decision was that instead of hiring you should have hired a secretary to do the typing and organizing the things for you. You could have only paid $10 per hour for those 2 hours, and you could have done extra law work for those 2 hours. So the penalty incurred by not taking the right decision is $90 per hour for those 2 hours, and that is the opportunity cost of not hiring the secretary. This same concept is used for discount rate. Discount rate is a critical economic parameter. Remember that we were discussing over here this equation. P is equal to F over 1 plus I raised to power n. Normally in this equation we have this I is called discount rate. Okay, interest and discount rates are sometimes synonymously used, but this discount rate could be quite different from the prevailing market interest rates. So I is discount rate here. And what is discount rate? It is the opportunity cost of capital. Opportunity cost of capital is the discount rate. So theoretically it reflects the opportunity cost of money to a particular investor, or in broader terms to a particular country. Normally the discount rates are dictated to the third world countries, is dictated by the IMF, the World Bank, Asian Development Banks. These lending agencies, they say that use this discount rate for your analysis. And as I said here, that this is a critical economic parameters. It can change the analysis, and we will see the example. And since the opportunity cost is linked to the prevailing condition within a given country, the discount rate, like the inflation rate, tends to vary often significantly from country to country. Normally, higher discount rates are used for developing countries or underdeveloped countries, and lower discount rates are used for developed countries. Because the argument is given that the opportunity cost of capital is quite high in developing countries, because any project you take up, you will have a higher return for that, and that is the logic used to putting higher discount rate for developing countries. So here we have an example that how this discount rate can change your analysis. We have 2 projects. The project A is the cost is $50,000 in the year 0, then next year, start of first year is $5,000 and so on, and then there is no cost, let's say, and the revenues are, or net revenues are there. Of course, first 2 years is nothing, then we have the next 4 years, it is $6,000. Here we have this project B, we have a cost of $10,000 and then there is no cost here. We have a revenue coming from the start of first year, we have 5,000, 4,000, 3,000, 2,000, etc. Now if you see, if there is zero discount rate or there is time value of money is considered 0, then the cost of in this one is 20,000 and the revenues are 30. So the difference is 10,000. So this means that this is bringing 10,000 profit if the discount rate is 0. And this one we have 5 plus 4 plus 3 plus 2 plus 1 is 15, and 15 is the revenue and cost is 10. So if the discount rate is 0, it is bringing $5,000. Now let's see the effect of changing the discount rate. We see, here we plot this one, the two projects. Project A, when there is 0% discount rate, we have 10,000, and when we have 0% discount rate, project B is at 5,000. As we start increasing the discount rate, the initially project A has a higher present value, it's a good project. Comparing to project B, we can see that it has a higher net present value, so this is a good project. But at around 7 to 8% or so, 8%, these two projects become almost equal. And then if the discount rate is further increased, we see that project B has a higher net present value than project A. So this means that our analysis will differ from country to country. If we are doing our analysis in United States or in Canada, where the discount rate may be 6 to 7%, we will select project A. If we are doing it in somewhere in Bangladesh or in some African country or some South African country, etc., South American country, we will see that we will select project B because project B has higher net present value at higher discount rates. This has effect actually. It is possible that the developing countries may go for those projects which have lower initial cost, but they may have higher operating costs. On the other hand, those projects which have higher costs, initial costs, and lower operating costs, they may be selected in projects in countries where the discount rate is quite less. Okay, so you got the concept here. It means that discount rate can change your analysis.